Okay, welcome back. Today's lesson is called the normal distribution, and just to clue you in, we're on page 776 of the textbook, and we're going to be looking at example number 10 in a moment here. You do not need graph paper for this lesson. You can do this lesson on regular paper because we're just drawing a sketch. This is a function. This is the normal distribution function. We're just drawing a sketch of it. We're not actually interested in precise location of points. So just a good sketch is fine. And let's go ahead and draw it. All right, the shape of this thing is called the bell curve. Okay, so this shape, just like we have the shape of a circle or a square, this shape is called a bell curve, and it's symmetrical. Okay, so I'm going to do my best to draw this as symmetrical as possible. Okay, and we have three lines of standard deviation to the right. Okay, so three lines to the right. These are called lines of standard deviation. Three lines of standard deviation to the left. Okay, the center line is the mean or the average. Yeah, let me kind of fix that. It's close enough. The center line is the mean or the average, or z equals 0. Okay, z equals 1, z equals 2, z equals 3. Just go ahead and get this information down. Z equals -1. Z equals -2, and z equals -3. Okay. Now, the center line is called the average. Okay, and the symbol for average is mu. Okay, I'll get to that in a minute. Here, let's put it up here. So this, I tell students to put this on the definition sheet, but it doesn't actually. It's not technically tested, but still, you need to have this information down. Mu. Okay. This is a Greek symbol. We run out of symbols in our own alphabet, so again, we borrow from the Greek alphabet. This is a U. This is a U with a tail. If you want to think of it that way, draw a U, put a tail on it. I think it technically represents the letter M in the Greek alphabet. I believe the name of this symbol is mu. It's like meow without the W. I'm sorry, it's like meow without the O. Okay, so mu. And mu represents population. Population mean, okay, or the average. And then we have another symbol called sigma. It looks like a circle with a hat, okay. This is called sigma. It is also a Greek letter. I'm not sure which one it represents, but sigma is the name. And sigma represents population standard deviation. Okay. Just getting information on our paper right now. Standard deviation. And then we have Z represents Z-score. Okay, Z represents Z-score. And we have to have, okay, so this is tested. I'm sorry, I should have drawn the line here. This is tested. Okay, quizzed and tested. What is the definition of Z-score? So let's go and write this. Definition of a Z-score. Okay, definition of a Z-score is the number of, here, let's just use a number hash. Definition of Z-score is the number of standard deviations to the left or right of the mean. Okay, and this is two-part definition. So the first part of the definition is what is a z-score, number of standard deviations to the left or right of the mean. Then you have the formula, z equals x minus mu over sigma. Again, you see your symbols. You see sigma, you see mu, the mean, okay, and then x, reminding you this is the x-axis. Give me one moment to check the camera. I just want to make sure. Okay, camera's on. Okay, I just got done making this whole video only to find that the camera wasn't even on. So I'm remaking the whole video again. Just want to make sure the camera is on this time. All right, so definition of z-score. Two-part definition. Okay, so you have to know what it means and then the formula. Awesome. Now, back to this. Okay, the center line. The center line is our average, okay, or the mean. So let's go ahead and put our symbol for mean. It's mu. It's a U with a tail. Okay? And if I said that the mean or the average age in our class is 15 years old, okay? 15 years old would be the average. 15 years old would be the average age in the class, and this is an x value. 15 is an x value. Okay, X values go on the bottom. Z-scores go on top. Let me say this. Z-scores go on top, and the Z-scores never change. The Z-scores never change. Z-score is always the same. The X values will change problem to problem. Why? Your average will change problem to problem. So if I say we're studying the students in this class, the average age is 15 years old. What is the X value? The X value is 15. And the Z-score for X value 15, Z-score is 0. Okay, so if I ask you, what is the Z-score for the average? Or what is the Z-score for the mean? Or the X value 15? The Z-score for the mean is Z-score of what? 0. Now, let's talk about Z-score for a minute. Again, reading from the definition, Z-score is number of standard deviations to the left or right of the mean. So Z-score of 1 means 1 standard deviation to the right of the mean. Z-score 2, if Z equals 2, that is 2 standard deviations to the right of the mean, or the center. Z-score of 3 means 3 standard deviations to the right of the mean, reading from the definition. So if I ask you what this means, guys, what does Z equals -1 mean? Okay, what does Z equals -1 mean? It means what? 1 standard deviation to the what? Left of the mean. What does Z equals -2 mean? Z equals -2 means 2 standard deviations to the left of the mean. And Z equals -3 means 3 standard deviations to the left of what? The mean or the center. Question. What is the Z-score for the mean? Okay. What is the Z-score for the mean? The Z-score for the mean is 0, meaning the Z-score of 0 means no standard deviations left or right of the mean. We are at the mean. Okay, so Z-score of 0 means we are not left or right of the mean. We are at the mean. Okay. Now, if I ask you, it's coming. What does a Z-score of 2.5 mean? Z-score of 2.5. Z-score of 2.5 means 2.5 standard deviations to the right of the mean. And if I ask you what a Z-score of -1.5 means, we're going to get into decimal Z-scores. -1.5 Z-score means 1.5 standard deviations to the left of the mean. Okay, so just kind of cluing you guys in on Z-scores, number of standard deviation. Don't have to understand necessarily what's going on right now, just follow along. Okay, this will all come together. It's actually pretty easy, okay? But there's a lot of information to put on paper, but once you see how this works, you'll just, don't worry. It's not that bad. Okay, so we've done much harder stuff than this. Okay, so center line is our mean. Okay, you guys will actually find this to be pretty simple. Now, total area of this curve. Total area is 1 square unit. I always tell students, think of this 1 square unit area. What are we talking about? This white region underneath the curve, this area that's underneath the curve, these regions in here. Okay? These regions have a total area of 1 square unit. I tell students, think of this as 1 square on the chessboard. Okay, think of this as 1 square on the chessboard. Okay, so if we think of this area in here, the area of 1 square on the chessboard, this area would be 1 square unit. Whatever this unit is, maybe it's a 2-inch unit. Okay, but it's 1 square unit, a 2 by 2. Okay, 2 3/4 inch, I think is proper standard size. 2 3/4 inch by 2 3/4 inch, or 1 square unit. We're not concerned with what the unit is, okay, whether it's in inches or feet, but it is 1 square on the chessboard. What am I talking about? This area in here, all of these regions, okay, these areas in here all add up to what? They add up to 1 square unit, or 1 square on the chessboard. So if somehow you could take the area underneath this curve and make it square, okay, it would be the same as 1 square unit. Whether that be 1 square foot or 1 square inch, we're not concerned. Okay, so I just want you to realize, think of this area under the curve as 1 square on the chessboard. Okay, now, looking at, okay, I'm going to erase this. I think we're done with this, yeah. Next, we're looking at what is probability. Okay, what is probability? No. I'm not done yet. Percentage of area. Okay, we'll get to probability in a minute. Percentage of area. Okay, what percentage, the total area is 1, what percentage of area lies within 1 standard deviation of the mean? Or what percentage of area is here, within 1 standard deviation? These two areas is 68% of the total area. Total area is 1. Okay, so this area is 68% of the total area. Now, I want you guys, this is called the empirical rule. You can refer to this. The empirical rule is on page 774. So if you look on page 774 of your textbook, you can find the empirical rule, these percentages. Very important that you know where it is. Page 774 of the textbook, silver box, middle of the page, says the empirical rule, 68% of the area lies within 1 standard deviation of the mean. Now, I recommend that you get a calculator out for this, so maybe pause the video. I want you to focus on what we're doing here, not the calculations. So maybe grab a 4-function calculator, something that will add, subtract, multiply, and divide. Okay, something very simple. I think your phone has a calculator on it. So 68%. Now we notice there's symmetry, so we're going to take 68% divided into 2 parts, 2 equal parts. If you take 68 and divide by 2, you get 34% and 34%. Now, the empirical rule on page 774 says that what percentage of area lies within two standard deviations of the mean. Okay, so within 2 standard deviations of the mean is 95, almost all of it, 95% of the total area underneath this curve. Okay, now 95%. So my question is now, what is the increase from 68 to 95? How do you find this? So I need to know, what is the increase? What is the increase going from 1 standard deviation out to 2 standard deviations out? What is this increase? To find the increase, you're going to take 95 and subtract 68. 95 subtract 68, follow along. Again, use a calculator. 95 subtract 68 gives what? 27%. Okay, so 95% subtract 68% gives an increase of 27%. And so the total increase is 27. Since we have 2 equal parts, take 27 and divide by 2. 27 divided by 2 gives an individual percentage of 13.5% and 13.5%. So each of these regions is 13.5, 13.5. Now, in the book is actually not as precise as we are going to be in class. Okay, the book says 99%, but what percentage is within 3 standard deviations of the mean? We're going to be a little more precise than the book. Within 3 standard deviations of the mean is 99.7%, almost 100. Almost 100. So close to 100, it'll blow your mind. 99.7%. Now, my question is, what is the increase? What is the increase? Very small area out here. What is the increase? From 95 to 99.7. We're looking for this little increase out here. So we take 99.7 and subtract 95. 99.7 subtract 95% gives 4.7%. So our increase is 4.7%. Now divide that into 2 equal parts. We get what? 2.35% of the area and 2.35% of the area. Now lastly, what is the percentage of area in these micro areas out here? If I ask students, what is the total percentage of the entire curve? What is all of the percentage of the entire curve? The whole percentage. Okay, being underneath this curve, the percentage chance of being anywhere underneath this curve is 100% chance. So if we take 100%, we want to find these micro increases on the end. Take 100%, subtract 99.7%, we get 0.3%. Now I tell students, think of 0.3 as 30. What is 30 divided into 2 parts? We want to divide this into 2 equal parts. 30 divided by 2 is 15. So we get 0.15 micro, 0.15% and 0.15%. So small it will blow your mind. I say this, 0.15% is 1.5 out of 1,000 chance. So small. So I tell students, hey, buy a pick 3 lottery ticket in the morning. You have a 1%. You have 1 out of 1,000 chance of winning the pick 3 lottery. That's about the same percentage chance as being in this micro area out here. These micro areas are 0.15% and 0.15%. Now, so I've shown you percentage distribution. Now let's talk for a moment about probability. So I want you to write probability. Okay, probability. And we read this, probability is represented by variable P. Probability, and how do we read this? How do we read this? Okay, what is the key word? This is an and statement. We read this as what? Between. Okay, so we say that probability is a value between 0 and 1. I ask students this question. Okay, so if I grab here, there are 2 pens. There are 2 pens in my hand. Okay, one is blue, one is black. I have 2 pens in my hand. One is blue, one is black. Okay, so 2 pens in my hand. What is the probability of drawing the blue one? Okay, there's 2 pens. What is the probability of drawing the blue pen? Okay, if I randomly draw with my eyes closed, I can't tell the difference. I can't tell the difference between the pens. What is the probability of drawing blue? Okay, Oh, I got black. Okay, what's the probability of drawing blue? Okay, so I hear this a lot. I hear students say 50% chance. 50% is the probability of drawing blue. No, that's incorrect. Guys, 50% is not the probability. 50% is a description of probability. What is the probability? What is the probability of drawing blue? Okay, probability of drawing blue is 0.5. What is probability? Probability is a value between 0 and 1. Probability of drawing blue is, okay, 0.5. Now, so if I ask you, what is the, okay, so 50% is description. Probability is a value between 0 and 1. So 50% is description. Probability is 0.5. So again, what is the probability if you flip a coin? What is the probability of flipping heads? Okay, we don't say 50%. That's not probability. Percentage is a description of probability. Probability is a value between 0 and 1. Okay, so let's see. You say probability of drawing or flipping a heads would be 0.5. Okay, so now 50% is 0.5 and 75% chance. Percentage is description of probability. The probability would be what? This is probability over here. Okay, so probability. 75% is description. Probability would be what? 0.75. If I said 99% chance, what is that probability? That is what? 0.99. If I say 100% chance, what is 100% chance? 100% chance is a probability of 1. Notice, what is the maximum probability value? 1. What is a 0% chance? 0% chance is a probability of 0. Okay, now what if I say a 3% chance? Okay, notice, we move the decimal. To go from 75% chance to probability, we take the decimal, move it where? 2 places to the left. To go from 50% to 0.5, we take the decimal and move it 2 places to the left. Okay? 3% chance. Take the decimal, move it 2 places to the left. What is our probability? Our probability is 0.03. Everywhere you see an empty space, put a 0. So 0.03 is the probability. Now, another thing you have to know, probability, I'm going to leave the 100% up here for a moment. Probability is equal to area. Area is the same as probability. Probability is the same as area. Okay, so if I say here, what is 100% chance? 100% chance is a probability. Probability of 1. Okay, probability of 1. Look at the curve. What is the total here? What is the total percentage chance of being anywhere under this curve? The percentage chance is what? 100% chance. What is the probability of being anywhere under this curve? The probability is 1. Now look, what is our total area? Our total area is what? Total area is 1. Okay? Now, look inside here. Notice that probability is the same as what? Area. Look inside here. I'm going to underline this 34%. Okay, so what is the percentage chance of being in this region right here? This area, okay, right here that's underlined. Okay, what is the percentage chance of being in this area? That's a 34% chance of being in this area. Now, my question is, what is that probability? The probability, move the decimal 2 places to the left, is a probability of 0.34. Now my question is, what is the area? What is the area? The area is the same as the probability, 0.34. Now, here, question. What is the percentage chance? What is the percentage chance of being anywhere, here, anywhere in these 2 areas? What's the percentage chance of being anywhere in these 2 areas to get combined? Combine. Take 34 and add 34. What's the percentage chance of being anywhere in these 2 areas? So I'm highlighting them. Anywhere in these 2 areas is what? 68% chance. Okay, this is percentage. And now we're going to convert percentage to probability. What is the probability? Okay, probability is what? Probability is 0.68. And what is the area of these 2 regions? The area is also 0.68. So we see that the probability and the area are the same thing. So this is what I need you guys to see right away. Now, so again, probability is a value between 0 and 1. Okay, I'm going to erase this because we're going to need this space. And probability is the same as area. Now back to this. Up to the top left goes total number. If given. Not all problems give a total number. Okay, so now this has to be drawn for every problem. So the hardest part, the problems are really, really easy. The hardest part about these problems is drawing the curve. Once you draw the curve, the problems are very, very simple. And the more you draw this, the faster you're going to get at it. So let's look at page 776, example number 10. Okay, so we're going to do problem number 10 off of page 776. And let's go ahead and set it up. So I'm going to erase this. And we're looking at, I'm just going to read it to you. Okay, and I'm just going to tell you the process, the thinking process we go through here. All right, so page 776, problem number 10 says, I'm going to flip it over. It says, the useful life of a certain car battery is normally distributed. Stop there. Stop there. Before we read anything else, guys, when you hear the words normally distributed, what do you draw? You draw the bell curve. You draw the bell curve. Okay, so, or the normal distribution function has the shape of a bell curve. So what does it say on number 10? The useful life of a certain car battery is what? Normally distributed. Stop there before reading any further. Let's draw the bell curve. Okay, so we're going to draw and put all of that information. Okay, so I'm going to do the best I can to draw this symmetrical. Okay. And how many lines of standard deviation to the right? Well, we have 3. Okay, 3 lines of standard deviation to the right and 3 lines of standard deviation to the left. Now the top line, top center line is z equals 0. Then we have z equals 1, z equals 2, z equals 3, z equals -1, z equals -2, and z equals -3. Reminding you, what does z equals 3 mean? Z equals 3 means 3 standard deviations to the right of the mean. What is our center line? Center line is where? Center line is the mean. Okay, so let's put our symbol mu for mean. Okay, it's a U again. It's a U with a tail. Okay, so you can think of this as a U with a tail. Okay. Center line is the mean, and z equals 2 represents 2 standard deviations to the right of the mean. Z equals -3 means 3 standard deviations to what? The left of the mean. Okay, now, within one standard deviation is what percentage of area? I should write this. What is our total area? Total area is always written here. This is going to be important for the next lesson. You guys have to know your total area always. So write this. Total area is 1 square unit. This is always written. Okay. Part of your grade on these problems is going to depend. Did you put all the information for this? Okay. So definitely, I'm definitely worried about. I'm looking for. Did you guys put all the information for your curve? What percentage within 1? So these 3 percentages are the most important. So we have what? 68% within 1 standard deviation of the mean. Now, to find these individuals, we're going to take 68% and divide into 2 equal parts. Again, you can use a calculator. If you've forgotten, take 68, divide by 2, we get what? 34% and what? 34%. Now, what percentage of area is within 2 standard deviations of the mean? Within 2 standard deviations of the mean is 95%. I tell students this. You don't have to remember all of your individuals. You just have to remember these 3. Because if you can remember the bottom 3, you can figure out what all of your individuals are. Now, eventually, you'll get to the point where you remember all of these. But for your test, remember, if you memorize the bottom 3, you can use these to figure everything else out. Watch. Okay, so 68% divided into 2 parts is 34. Now, 95%. What is the increase from 68 to 95? Again, how do we find the increase? We take 95, subtract 68. What do we get? We get 27% increase. 27% increase divided into 2 equal parts is 13.5% and 13.5%. And now, what percentage within 3? Within 3. Little different from what the book says. Within 3 is what? 99. Almost 100, guys. Almost 100. 99.7%. Okay, so what is our increase from 95 to 99.7? From 95 to 99.7, these smaller areas. Okay, so we're going to take 99.7, subtract 95, and we get 4.7% increase. Now divide that into 2 equal parts is what? 2.35%. And what else? 2.35%. And lastly, we want to find these micro areas on the end. So remember, the total area, or the total percentage of the entire curve, total percentage of area is 100%. Take 100%, subtract 99.7%, we get what? 0.3%. And if we take 0.3% divided into 2 equal parts, we get micro areas of 0.15% and what? 0.15%. So these are the micro areas. Now, okay, up here to the top left goes what? Total number. Okay, total number if given. Okay, some problems give it, some problems do not. Okay, so let's see. Is this off the board? Okay, let's go to solving the, well, we're not quite ready. Okay, we're not quite ready to solve the problem. We still have to get the information out. Okay, so problem number 10 says, the useful life of a certain car battery is normally distributed. When you hear the words normally distributed, you draw all this information with your z-scores, your percentages, your total area, and you're ready for your information for your problem. Now, let's keep reading. It says with a mean of 100,000 miles, mean is your average, or 100,000. Mean of 100,000, that's mu. Okay, so we're going to say mu, or the mean, the average, mu, is 100,000. So what is our center? What is our center? Our center is what? 100,000. This is the x-axis, guys. What is our x value that we're given? 100,000 is the x value given. That is our center. Now, where is our center? Center is at 100,000. You guys are used to looking at the center as here. Here's 1, 2, 3, negative 1, negative 2, negative 3. You guys are used to looking at center where? You guys are looking at what? A center of 0 on your graphs. You guys are used to looking at a center of 0. Okay? And we call this the y-axis. Well, our center is not at 0. Our center, the x value for our center is 100,000. Okay? Don't get center confused with z-score. Okay, z-score is different. Center, x value. What is our center? Center is 100,000. Okay, so this is not centered at 0. Okay, so that's important. Now, some other information from the problem. Other information from the problem says the standard deviation is 10,000. Now, our symbol for standard deviation, I tell students, write this out to the side somewhere. Sigma equals what? 10,000. Okay, this is our symbol for standard deviation, a circle with a hat. And it also says the company makes 20,000 batteries a month. So do they give us a total number of batteries produced? Yes. They said that the total number of batteries produced is 20,000 batteries in a month. So go ahead and put that as your total number. Now, we're almost ready to start the problem. It's pretty simple now. Watch. Okay, so again, x values are on the bottom. X values are on the bottom. They're down here. Okay? X values will change problem to problem, but what will never change? What will never change? Your z-scores will never change, and this is going to be the way we solve problems, by using z-score in the future. But for now, okay, we're just looking at, notice, I want you guys to notice tonight that your x values, the values on the bottom will change, but your z-scores problem to problem will not change. Now, standard deviation, okay, we already talked about mean. Okay, the mean is 100,000. That is our center. Okay, standard deviation is distance. You guys can think of this as distance. Now, I told you that this line, z equals 1, represents one standard deviation to the right. Now, if a standard deviation represents distance, and our distance is 10,000, this means that one standard deviation has a distance of 10,000. So my question is, how far is it from our center to one standard deviation to the right? From our center, one standard deviation to the right is a distance of what? 10,000. So to go one standard deviation to the right is to take the center of 100,000 and add 10,000. So to go one standard deviation to the right is to add 10,000 to 100,000, which gives us 110,000. So to go to the right is to add 10,000, add 10,000, add 10,000. Each of these distances from one standard deviation to the next is how far? It is 10,000. Okay, it will change problem to problem. So to go from 100,000, one standard deviation to the right is to add a standard deviation, or add 10,000 to 100,000. So let's add 10,000. Let's do it again. Add another 10,000. So 100,000 plus 10,000 is 110,000. Plus another 10,000 is 120,000. Plus another 10,000 is 130,000. Now, to go to the right is to add the distance, or to add your standard deviation. To go to the left is to subtract. So our center is 100,000. To go to the left is to subtract a standard deviation. So start subtracting. 100,000 subtract 10,000 gives what? 90,000. Now students, don't do this, don't do this, don't do this. Students do this all the time. They write their 90,000 here. They write their 90,000 here. Hold on. Is 90,000 written halfway between? No. No, 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 no. No, 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 no. What is 90,000? 90,000 is this line of standard deviation. So write your 90,000 underneath that line. Write your 110,000. That represents this line, this standard deviation. Okay, underneath this second line, z equals 2, write 120,000. Underneath this third line, write 130. Now to the left, subtract 10,000 gives 90,000. Subtract another 10,000 gives 80,000. Subtract another 10,000 gives 70,000. Now, before we go any further, let me just kind of clarify some things. On the bottom, this 70,000, this 80,000, this 90,000, 100,000, 110, 120, 130 are your x values. These will change problem to problem, but what will never change are your z-scores. So now my question is this. Okay, what is the z-score for x value 120,000? What is the z-score for x value 120,000? Okay, well x value 120,000 is here. Our z-score is what? 2. Meaning that 120,000, this x value, is 2 standard deviations to the right of the mean. Question. What is the z-score for x value 90,000? What is the z-score for x value 90,000? X value 90,000 has a z-score of -1, meaning that 90,000 is 1 standard deviation to the left of the mean. Now, what is the z-score for x value 70,000? 70,000 has a z-score of -3, which means that 70,000 is 3 standard deviations to the left of the mean. Now, let's go backwards. What is the x value for z-score 3? What is the x value for z-score 3? So if I say z-score is 3, what's our x value? X value is 130, meaning that 130 is 3 standard deviations to the right of the mean. What is the x value for z-score 1? Z-score 1 has an x value of 110,000. So just want you guys to see the difference. Now, let's go to these problems. The problems are so simple. Okay, so let's go. A, part A. Now, I don't care what the problem asks, you're finding 3 things, and they're very quick and easy to find, right? Percentage, probability. What is probability, guys? Probability is the same as what? Probability is the same as area. So percentage, probability, write probability slash area, same thing, and then write how many. Okay, so let's go to the problem. The problem says, part A says how many batteries, okay, how many batteries will last between 90,000 and 110,000 miles? Guys, ignore the how many. Ignore the question. How many? How many? Okay, what did I tell you guys are finding? You're finding what? Percentage, probability, how many? For every question, no matter what the question asks. Notice part A says how many. Notice that part B says how many. Now go down to part D. Part D, page 776, number 10, part D says what is the probability. It does not matter. If they ask you for how many, you're finding all 3. If they ask you for probability, you're finding what? All 3. Okay, because all 3 of these are interrelated. Very simple. Watch. So the first question, we're concerned with where are we? It says between what? Between 90,000 and 110,000 miles. Between 90,000 and 110,000. Between 90,000 and 110,000. Okay, so where are we? Circle 90,000, circle 110,000, and between, obviously we know what between means, we're looking at these 2 areas. So I want you to highlight these 2 areas. Between 90,000 and 110,000, we're in these 2 regions. So what do we have to do? We want to find percentage, probability, and how many. What are we going to do with these 2 percentages? We're going to add them up. Between 90 and 110,000, add 34% area, add 34% area, what do we get? A total percentage of area of what? Total percentage of, hope it's right here. Total percentage of 34 plus 34% gives what? Percentage of 68%. That's our percentage chance. Okay, this is our percentage chance. To go from percentage to probability, we move the decimal 2 places to the left. Okay, move the decimal 2 places to the left gives us what? A probability of 0.68. Okay, so our probability is 0.68, and our percentage is 68%. Now, we want to find how many. Okay, it's pretty simple. To find how many, watch this. We're interested, notice, how many batteries total were there produced? This curve represents how many batteries. This curve represents 20,000 batteries produced. So we're interested in 68% of that total. Okay, so we're trying to find 68% of 20,000. To find 68% of 20,000, well, 68% can be written as 68 over 100, and of means multiply. So we're looking at 68 over 100 multiplied by 20,000. Now watch this. 68 over 100 is 0.68 times 20,000. Okay, 68 over 100 is the same as 0.68. Notice, okay, this is your percentage, and notice 0.68. What is 0.68? 0.68 is your probability. So to find 68% of 20,000, take what? Take the probability and multiply by what? The total number of batteries produced. So to find how many batteries, take your probability, 0.68, and multiply by what? Multiply by the total number produced, 20,000. You can use your calculator. 0.68 times 20,000 gives what? 13,600 batteries produced. Okay? So most of the batteries produced, 68% of them, more than half of them. Now, tell students this, to help you understand this curve a little bit. You ever hear the guy buys a truck? Someone buys a truck. They tell you this story, you know, I bought this, let's say Toyota. Okay, so my favorite truck is Toyota. I believe Toyota is the best truck on the road. But, you know, are there some out there that aren't so good? Yeah. But for the most part, you hear these stories. You know, maybe it's someone who drove a Ford. Maybe it's someone who drove a Toyota. But you hear these stories of, I bought this truck, and it lasted me for years. 30 years, you know, and this truck went over 500,000 miles without a problem. I've heard these stories before, and I know we all have, okay, maybe 300,000, but the truck lasted forever, okay? Look at this. We're talking about lifespans of batteries here. Now, let's just think in terms of truck. Okay, let's think of up here as the truck lasting forever. What is the percentage chance that if you walk into a store or a car lot and you buy a truck, what is the percentage chance that your truck is going to last over 500,000 miles without a problem? What is the percentage chance? Very small. About the same percentage chance as winning the Pick 3 lottery. Very small percentage chance. Only 1.5 trucks out of 1,000 trucks will you buy that will last more than 500,000 miles without a problem. Okay? But then you hear those horror stories of someone who bought a Ford. Okay? Fix or repair daily. No, I'm just joking. Okay. All right. I got to bash Ford a little bit here, but anyway. So Ford, okay, so whatever. He buys a truck, and you hear these horror stories. I bought a brand new truck, and I'm in the shop. You know, I'm in the shop before 10,000 miles. The whole transmission's bad, and they got to replace the whole transmission. And okay, this is rare. This is not the common case. Okay, this is common. What is the percentage chance? What is the percentage chance of buying a bad battery or buying a bad truck? A truck that has problems from the get-go. A truck that doesn't last very long at all. What's the percentage chance? Also, very, very small. But what is the likelihood that you go to a car lot and you buy a truck that's going to last between 100,000 and 200,000 miles? It's going to last a good amount of time, okay, with minimal problems. What is the percentage chance? Most of your trucks are going to lie in here. I say this, it's like 20,000 batteries. You walk in a store, 20,000 batteries are on the wall. Now I say 20,000 is a huge number, guys. It would like fill 20,000 batteries, like fill Walmart 2 times over. Okay, 20,000 batteries, lots of batteries. Okay, so you got 20,000 batteries in the store. You walk in, you're just like, oh, it's like battery paradise, you know. Okay, no, not really. But anyway, you walk in, you see all these batteries, and you're trying to pick, okay, which one? Well, as you know, what is your chance? What is your chance of picking a battery that's going to last here? Let me say this. What's your chance? You hear that guy, I bought that battery. It lasted me forever, man. I never had any problems with that battery. It lasted forever. What is the chance of you picking a battery off of that shelf and it being an awesome battery, one that you never have problems with? Very small chance, but could it happen? Yeah, it could happen. Okay, what are the odds? You hear the guy, I bought the same battery. I bought that same battery, and I had problems. A month later, went out to start my truck. The truck was dead. Okay, what is the chance of this dude walking in and buying the one battery on the shelf, or whatever, very small percentage of batteries on the shelf? He happens to grab the one that just has problems, you know? It's a very small chance. But what is the likelihood if you buy a battery? What is the likelihood if you buy a battery that's going to last somewhere between 90 and 110,000 miles? About 68% chance. What's the percentage chance if you buy a battery that's going to last somewhere between 80,000 and 120,000 miles? a 95% chance. This is how we analyze product consistency. And I don't have time on this video, but I talked to students about how to make money here. You make a lot of money off of warranties. Okay, you make a lot of money off of warranties here. Let me just give you the gist, real quick gist. Okay, if the warranty, we sell these $5 warranties, everyone pays $5, so you've got 1,000 people. 1,000 people pay a $5 warranty. Okay, everyone pays a $5 warranty. You just made $5,000. The company just made $5,000. Out of 1,000 warranties, and your warranty says if your battery breaks before 70,000 miles, we'll replace your battery. Okay, if your battery doesn't last 70,000 miles, we'll replace your battery. But look down here, 70,000 miles. How many batteries are going to last less than 70,000 miles? Only 1.5 out of 1,000 batteries. Okay, so the company sells 1,000 warranties for $5 a warranty. The company makes $5,000 in warranties. Their cost to replace the 1.5 batteries or 2 batteries that go bad is about, $100? The company makes $5,000 off the warranties. It only costs them $100 to replace. They just made a lot of money. Do you think they're willing to pay the math guy, the guy that figures this out, the math guy? Hey, the math guy can make them $5,000. You think they're willing to give them a cut of $2,000? Absolutely, absolutely. Okay, so normal distribution is a way to deal with product consistency in industry. Okay, all right. So, your product consistency should be normally distributed if you got or some sort of, there's several distributions, but most normally distributed or close to. Now, B. Okay, so we're looking at B. Okay, get off this topic. B says what? You guys can, if you ever don't want to listen to this, just fast forward. You guys can get to the next problem. Okay, so how many batteries will last more than 120,000 miles? More than 120. Okay, so more than. What does more than mean? More than means to the right or to the left. Hopefully you guys say more than 120,000 means what? To the right. Notice, the question says how many batteries? How many batteries? Are we finding how many? No, we're finding all three, right? For every problem, no matter what it says, you're finding what? Percentage, probability, slash area, probability is the same as area, or how many. Now, one thing I need to say, students came back with their homework. Some of them are done with this. Many of them are done. Came back with their homework. They said, we couldn't find how many. Well, okay, I'll say this. The problem has to give you a total number, okay? Number 12 and number 13. Number 12 and number 13 on page 776 don't give a total number. So if they don't give you a total number, then you don't have to find how many. You can only find how many if they give you a total number of batteries produced or a total number of men surveyed or whatever. Okay, so if they don't give you a total number, you cannot find how many. But if they give you a total number, you're required to find all three. Okay? But you can always find your percentage and your probability. All right, so three things. For this problem, they give us a total number. We're finding all three. It says more than 120,000. More than 120,000. Guys, where's 120,000? 120,000 is here. More than means to the right, not to the left. Okay, so more than 120,000. We're looking at these two areas. I'm highlighting them. These two very small areas out here. Okay, so more than 120,000. We are here. I'm darkening it. Okay, so we're starting at our borderline to the right. Now we're adding up these two areas. So we're going to add up 2.35% and 0.15%. So 2.35% and 0.15%, we're interested in the percentage chance of a battery lasting more than 120,000 miles. 2.35 plus 0.15 gives 2.5%. So we have a percentage of 2.5%. Again, you can use a calculator for this if you need to. I want you guys focusing on the concept, not the calculations. Now, to go from percentage to probability, what are we going to do with the decimal? We're going to move it two places to the left. What do we have? Point what? 0.025. Notice there's a missing number here, so we put a 0. Okay? Now, to find how many, we take our probability and multiply by what? Total number. Or take our area and multiply by total number. Take your calculator, 0.025 times 20,000 gives what? 500. Okay, 500 batteries. Now 500, guys, 2.5% is very small. Students see 500, they think that's big. No. 2.5% is only 2.5 out of 100. Extremely small. Okay, 500 is extremely small compared to 20,000. 20,000 is a number that will blow your mind. It is huge, guys. We talk in terms of these big numbers, a million, a trillion. You know, let me give you a concept of trillion. Trillion is don't even try. Okay, I said this in a couple videos ago. A trillion. If you try to count to a trillion, 1, 2, 3, 4, 5, 6, 7, faster. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You try to count as fast as you can to a trillion. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, you're counting, you're counting, you're counting. Guys, you can count as fast as you want. It's still going to take you, I calculated this, 10,500 years to count to a trillion. 10,500 years. You can never do it. No one will ever be able to count to a trillion. Nope. Okay, so 20,000 is huge, guys. Take you a long time just to count to 20,000. 500 is micro small compared to 20,000. Let me give you perspective. 500, we think of these numbers as about the same size, not even close. 500 is about the same amount of money as you make in 3 days. 20,000, this is about the amount of money you make in a year. Okay, so there's a big difference here. Okay, so 500 versus 20,000, big difference. Part C, let's get this done and be done. All right, Part C says, how many batteries will last less than 90,000? Less than 90,000. So less than 90,000 means what? To the left. So Part C, again, we're finding three things. Percentage. What else? Percentage. What else? Probability. What else? Slash area. What else? How many? Okay, so we first find our percentage. Less than 90,000. How many batteries will last less than 90,000? What is less than? To the left. Okay, so we're starting at 90,000. This is our border to the left. So we're highlighting what? These three areas. Highlighting these three areas. Okay, so we're adding these three areas up. So we're adding 13.5%, 2.35%, and 0.15%. Let's add them up. 13.5%, you can use a calculator, plus 2.35% plus 0.15% gives a total of 16%. Okay, write that here. I tell students, think. Now, I want you to have this memorized, that this is 16%. What do these three areas add up to? 16%. What do these three areas add up to? 16%. But look, guys, what's half the percentage? Half of the curve is what percentage? Half the curve is what? 50%. What percentage of area is to the left of the mean? 50%. What percentage of area is to the right of the average or the mean? What percentage is to the right of the average? 50%. What percentage is to the left of the average? 50%. Watch this. Take 50% on your calculator and subtract out 34%. Take 50, subtract 34. What do you get? 50 subtract 34 gives what? 16%. Do you see that you could have just taken 50%, subtracted out this white space here to give you this area? 50 subtract 34 gives what? 16%. Now, you need to have these three areas memorized. 13.5 plus 2.35 plus 0.15 is what? 16%. Great way to memorize this is what is 50 subtract 34? 50 subtract 34 is 16. So we get 16%. Now to find the probability of the area, move the decimal 2 places to the left. What do we get? 0.16. 0.16. Here. 0.16. Now to find how many, we take the probability, 0.16. Here, let me erase this. Okay, we take the probability, 0.16, and multiply by what? Total number, 20,000. 0.16 times 20,000 is 3,200. Still very small. 3,200 is still very small in comparison to 20,000. Now, lastly, part D, or question D says, notice in question D it says, what is the probability? Guys, are we finding just probability? No. We're finding three things. What is this? Percentage. What else? Percentage. What else? Probability. Slash what? Slash area. And what else? How many? Okay, so percentage, probability, slash area, or how many. It says, what is the probability, whatever. What is the probability to drive a car? It will last between 80,000 and 110. Okay, so erasing this. I'm just trying to get this back. I'm going to erase this stuff. Erasing this. I don't want to get confused. Okay, and erasing this. All this. Between... It says, what is the probability that your battery will last between 80,000 and 110? So circle 80, circle 110. Between means obviously, okay, we're good here. Between, I'll say mark 80,000, mark 110,000. We need to know our border. Between means these areas. So highlight this 34%, highlight this 34%. We're between 110 and 80, or between 80 and 110, reading left to right. Highlight these three areas, So we're adding up 34% plus 34% plus 13.5%, all three of these. And 34 plus 34 is obviously what? 68% plus the 13.5. So we have 34 plus 34 is 68 plus 13.5. 68 plus 13.5 is 81. 68 plus 13.5 gives 81.5 what? 81.5%. So we get a percentage of 81.5%. Convert this to probability, move the decimal 2 places to the left, is 0.815. By the way, 0.815. What's our total area? Total area is 1. Is 0.815 close to 1? Yes, it's close to 1. It's almost all of the area. Where does most of your area lie, guys? Right here. So 34, 34, 13.5 is 81.5%, almost all of your area. Area of 0.815. To find how many, we take 0.815 multiplied by what? 20,000. 0.815 times 20,000 is 163 with 2 zeros, or 16,300. There are 16,300 batteries that will last between 80,000 and 110,000 miles in this batch. And tonight, if you guys missed class and you're trying to catch up, the homework for this lesson, pretty simple. It's pretty easy homework. The hardest part about this is drawing the curve. Page 776, numbers 11 through 13 all. And next video we will talk about what happens when our values do not lie right on these lines of standard deviation. So anyway, great job. Good luck on your homework, guys. Take care.